In example 4, we are going to deal with an integration involving a trigonometric function which is captured inside an square root. The first thing you want to do when you have this kind of situations is to try to get rid of the square root so that the expression could be expressed as a integrations without the square root. You look at the expressions of the integrand, which is something like, say, some expressions. So what you want to do is try to cast the argument within the square root to be in the form of some square of some expression y, so that finally you can cast it in terms of y. So how are you going to cast the expression of an integrand function with a square root into one without a square root? This could be done by making use of the trigonometric identity that relates cos of 2 times x into the form of the square of either cos function or sine function. So you relate cos 2 times theta to be either 2 cos theta minus 1, or this is equal to 1 minus 2 sine square theta. Let's see how you can cast away the square root by using this identity. So what we're going to do is to rewrite this into 1 plus cos 2 theta equals to 2 cos 2 theta. And then what you do here is just to replace theta by 2x. So you rewrite the whole equation with cos. So you have 2 times 2 theta, which becomes 4x. Then right hand side will become 2 cos 2 of 2x. So that would be able to rewrite the expressions of these integrations 1 plus 4x as 2 cos square 2x. So that is the applications of the identity of the trigonometric function. The integration is now cast into the form that involves only cos 2x. The integration of cos 2x is quite straightforward, which is just equals to sine 2x divided by 2. Since we are dealing with an indefinite integral, we have to add in an constant at the back. So you simplify this a little bit, that will become sine 2x over square root of 2 plus an arbitrary constant. So that is the solution to the integrations of this trigonometric function. The conclusion for this video is that we have shown you how to perform integration for the function that involves the square root of 1 plus cos 4x. The main strategy is to get rid of the square root sign. This could be done by deploying the identity that relates the cos of two angles to the square of the cos of an angle through this identity. Using this identity, we can then cast cos 4x in terms of 2 times cos square of 2x. Then the integrand that is expressed originally in the form of a square root can now become an integration that involves only cos of 2x. So here you transform the integrations that involve the square root of cos 4x into a term that involves only cos 2x without the square root. Then the integrations involving cos 2x can be straightforwardly obtained.